Hello everyone, good morning. Today my group and I are excited to present our major assignment on linear algebra. My name is Jovito and this is my friend.
Hello, my name is Erlan Putra Rochmanda.
So as we know, linear algebra is fundamental area of mathematics that deals with vector, matrix, and the system of linear equations that arise from them. It serves as a cornerstone for various fields including physics, engineering, computer science, and economics. Understanding the concept of linear algebra is essential for tackling complex problems in this area. So in our presentation, we will explore several key concepts in linear algebra. First, we will discuss vectors, which are mathematically objects that have both magnitude and directions. Vectors can represent quantities such as force or velocity, and they can be manipulated through operations like addition and scalar multiplications. For example, if we have two vectors representing force acting on an object, we can find the resultant force by adding these vectors together. So next we will delve into matrix, which are rectangular arrays of numbers used to organize data and express linear equations compactly. Matrix allow us to perform various operations such as additions, multiplication, and finding inverse. They play a crucial role in solving system of equations or performing linear transformation. So our focus will also include practical application of these concepts through three specific techniques for solving system of equation. First is Cramer rules, and then the second the inverse matrix method, and then the Gauss-Jordan method. So in Cramer rules providing straightforward way to find the solution using determinants, and it's particularly useful when dealing with small system of equation. And then the inverse matrix method involves calculating the inverse of a matrix to solve the variable directly. This method highlights the relationship between matrix and their corresponding linear equation. And finally, the Gauss-Jordan method is a systematic approach that transfers an augmented matrix into reduced raw echelon form, making it easy to read of the solution. So through our presentation, we will illustrate this method with examples to demonstrate the effectiveness in solving real-world problems. So let's dive into the fascinating world of linear algebra. We hope you find the exploration enlightening and engaging.
Let's start by explaining the system of the equation. Yeah, the system of equation is first the 2x plus 3y minus z equal 5. Second one is 4x plus 4y minus 3z equal 3. The 3 one is the 2x minus 3y plus z minus equal 1. First, we will explore the unique approach in solving this equation. The first one, we're using the Cramer rule implementation. The first one, we use the because we are using Cramer rule, we find the x equal x Cramer, y equal y Cramer, equal z Cramer. In this Cramer rule implementation, the first one we use the Cramer rule because definition of the Cramer rule is the variable is a and b. The second one is because we must find the determinant for the matrix. We use the determinant and matrix. This is for the return the matrix equal because like coefficient matrix. We must substitute. This is for the return for the using the matrix. The second one is for the determinant. If the sum equals 0, so the value is error, the system will not be unique. So it makes a condition if the d mean is the determinant, is a is from here. If is here is 0, so this will print this text. After that, if the d1 we must create the d1, d2, and d3. After that, this is code for the d1 like b0, a01, and a02, like and b1, a11. After that, a12. The third one is b2, a21, and a22, etc. But for the D2 and D3, it's same like the we are says in this code. After that, we must implement that solve the x, y, and z. For the x is the code is determinant is D1. D1 is from like this one. After we solve this one and divided by the d. The d is from here. So after that the y is determinant is for the d2 equal d. Z is determinant d3 equal d. Yeah. After that return the x, y, z in mathematics.
So we go to infer matrix method implementation. The first we need to find the definition first. You can see here the definition of the def infer matrix method is A and B. So these functions also takes matrix A. You can see matrix A and matrix B. So after that we inverse the calculation like def inverse matrix that equal determination matrix. So these nested functions calculate the inverse matrix A using the determinate and adjugate. So you can see the main logic like compute the inverse of matrix A, multiply the inverse vector B to find the solution vector x equal A minus 1b. You can see here. So after that, we do like def determinant matrix, like what I say. This is a coefficient, and then after an inverse matrix, and then x equals sum, A inverse, and then for I enrich len A and then return to X. So right now go to Gauss method implementation.
Yeah, for the Gauss method implementation, first we must use the definition. We have def Gauss Jordan is method. The variable is A and B. The second one is for the what I say is the n because len I said len because equal apa in this a variable for this is the condition if the for in rank is equal n is like this one. So this make diagonal element is 1 and normalize the row. So dia stand for diagonals equal dia I use for it depends for it's the diagonal words, but I use diag and equal A is E is like for the matrix for G in the range n, and this is the code. After that, for the make element above and below the diagonal 0 for the K in range equal n if K K is displayed the variable E, the factor is the factor is A, K, and E is K from here. Yeah, this is the repetition. After that, we cannot move to the B, and after that we must input the matrix. Yeah, because after because we use the repetition and we just make it to one things to run in one single command. Yeah, so we must despite this input to the code. The first one is A is 2 3 and minus 1. The second one is 2 4 4 and minus 3. The third one is 2 minus 3 and 1. The B is 5 3 and minus 1. After that, after we done this code, after that we just call the function, not function but the variable, and like this x Kramer, any y Kramer, z Kramer sama dengan equal Kramer rule a b. This is like for this one. Yeah, after that for the x Kramer and we just print the solution, and after that we just same also with the solution for the inverse metric, and after that we just same doing that with the Gauss Jordan. We just call the function, and after that we yeah after that we just structure very well, and this have the same result. Yeah, maybe my friend wants to give some more.
So our conclusion, finally, we print result from each method to compare solutions. So you can see this structure. The structure approach allow us to solve linear equations systematically, implement and turn code. Each method has its own strengths and can be chosen based on a specific needs or preference. So this our final for presentation. Thank you very much, and we hope this video can help the viewers to understand this program how to run without library. And once again, thank you very much, everyone.
Yeah, thank you. See you.
See you.
Bye
Bye
bye.
bye.